Hey everyone, it's Nick. Welcome back to another duality repair video. I recently bought this lot of 6 Fluke 8050A benchtop digital multimeters. And I already plugged them all in. I tried to turn them all on and really none of them displayed anything except for the bottom one. The display was a little messed up anyway, so we'll see if I can take all 6 of these and make at least one good one, maybe a couple. I don't have a benchtop multimeter, so it'd be good to have one out of this. Most of these are in fair to poor condition cosmetically. I'm not worried about adhesive or anything like that. I can remove that, stickers. But anything cracked, like this one, you can see the front bezel's cracked. I'm going to say that one's gone, cosmetically anyway. There's a few others that have some chips and scrapes, but there are a few that are in pretty good shape, so I'm going to try and make one, at least one good one, maybe 2 or 3 out of these. So let's zoom in on one of them and take a look at the front panel. Here's a closer look at the front panel of one of the units. They're all pretty much identical, other than 3 of them have a little battery charge status LED right here. This one doesn't have it. They are all the same model, at least that's what their designation shows on the front panel, so I'm not sure what that battery charge, why that's on some of them, not the others. I'm sure we'll figure that out as I open them all up. But fairly simple on the front. You have this little LCD display. This is going to be a concern. As these can wear over time and some of them might be broken or damaged. And then you just have, it's all push button, right? So you have a power on, off button. You have this relative on, off button. I'm not sure exactly what that does. I assume measuring voltage relative to something else. I'll have to look in the manual to see exactly what that is. On the left we have capability of measuring AC and DC waveforms, right? Or voltages, and then here's where you select your measurements. So you're either going to measure volts, milliamps, or resistance in ohms, and then here's where you can all these selectors show the different scales within those measurements. So within volts we have 200 millivolts, 2 millivolts, 20 millivolts, 2 volts, 20 volts, 200 volts, and it looks like we can go all the way up to 1000 volts DC, so that's nice. And then in the milliamp range, we can go down from 20 microamps, 200 microamps, that's as nice, all the way up to 2000 milliamps, which is 2 amps, so that's not bad. And in the resistance, we start off in the 200 ohm range, and we can go all the way up to 20 mega ohms, also very nice. So if I get at least one of these working, it'll be a nice, handy little benchtop multimeter to coincide with the standard multimeter that I have. So I think I'll just start with this one. There's no reason why I shouldn't start with this one over any others, so I'll open this one up. We'll take a look inside. Before I open it, I suppose I should show you what it looks like when I power it on. We at least do have a display, but it's definitely not correct. First of all, something is drifting. Let's see what happens if I change modes here. So I'm in the volt mode, current mode, KO mode. That one changed. But the display looks to be a little wacky, so hopefully that can be resolved. But if not, I'm sure at least one of these others will have a good display. So anyway, as a reference, that's what this display is doing, the one that I'm going to open next. Okay, here's the unit removed from the case. Disassembly couldn't have been easier. There was one screw on the back, and the whole thing just slides right out. Very easy. I did a very small amount of work already, so obviously this is not how it is laid out internally. This display board here is sitting on top, like this, screwed in. So I unscrewed it and folded it over just so we can get easy access. It's pretty simple. There's not much going on in here. Obviously there's 2 boards. We have our power board over here on the left, and then our LCD display board on the right. Pretty simple. And since we're having display problems, let's just dive right into the schematics. There's only 2 pages for schematics. This one has the power as well as the display up here. And so we know we have power for sure, because we do show something on the display. We're having issues with the display, so let's zoom in on the display here. It's laid out exactly how it is on the actual display. So we have, looks like we have this BT, which I think is battery, and then you have plus here, and then you have your 4 7-segment displays, and then you have some other dB, HV, and relative there. And so I assume when you power it on, these should all be, close to 0 or something. They should all be reading. And obviously, I think we were missing number 3, and we were missing part of 2, something like that. So obviously, each of these 7-segment displays is controlled by an individual IC. And the one we were most concerned with was, I believe, the second one. Second or third. So that's going to be U13 or U14. So if we look at those, they're all laid out identically. Pins 9 through 15 control the output with the reference to pin 16, which is ground. So let's take a look at a good, a functioning 7-segment display, which I believe was this last one here. And we'll check the outputs relative to ground, and we'll compare them to our bad one, which was 2 or 3, and see what we're getting. So let me plug it in and power it on. Alright, I'm powered up. And we might as well just look at the display. Yeah. And it's upside down right now, remember that. So this is actually the furthest right. And I can see, I don't know if you can see that. See when I put pressure on it, the display changes? So that tells me it may be a connection issue somewhere. Let's just take a look. So again, we know that the furthest right is working. Again, this is upside down. And it's the third one that's not working well at all. It shows nothing. And that one is here, which is going to be U. That's tough to read. 12, 13, 14. U14. So that's going to be right here. So let's use one of these others for reference. Maybe this one. Put my meter here. And we should have some sort of small DC voltage. See if I can fit it right here. It'd be nice. I can slide this up. There we go. Okay, again, let's test a functioning one for reference. And we have pin 16. Let me see. Pin 16's up here. This one we know is working. So 16 to this pin, negative 2.5. Next pin, negative 2.5, 2.5. Okay, so to display one of the 7 segments, we need approximately negative 2.5 volts. So let's take a look at our problem right here, U14. Let's do the same thing. Ground probe on the ground and negative 2.5. I'm just going to skip a few, negative 2.5, negative 2.5. Okay. So this is outputting the proper voltage to our LCD display, but for some reason it's not working. And as I said, since I can apply a little pressure and that changes the reading, the readout, I think it's going to be a connection issue. So I'm going to power it off. I'm going to see if I can disconnect this somehow from the board. I'm not sure if it's soldered in or what. And we'll take a closer look to see if there's anything wrong there. So I was able to remove the ribbon cable really easily. I've never seen a mounting like this, but basically it's just kind of pressed into place against the board here. And so you press it into place, it seats around. There's these holes on the edge of the cable here, and they seat around these mounting posts. And then they push up flush against the board here, and then you just press this strip down onto it, tighten it down, and it makes contact. So that's interesting. So all I had to do was disconnect this. So now we have the board separated, and I noticed that, so I took these 2 screws out, and it looks like I will be able to unmount this. And you zoom in on here, I already see something. So that's not a black hair, that's a crack here. So I wonder what it's going to look like when I take it apart. Let's take a look. Let's see how. I'm not sure how hard it's going to be. I don't think it's going to be too hard. Tools. Let's start with a flathead. So it looks like it's clipped into place on top here, and of course it was screwed on the bottom, but it's still rigid, so I'm going to try and separate it here. Sure, the plastic's old and brittle by now, which is probably why it cracked on that outside there, so I'm going to try and be careful. There we go. Okay, that does pop out. And let's see what happens. There we go. Okay, there's our screen. And it just slides right out. There we go. Let's take a look. Oops. Oh. Alright, so here's a strip that was on the screen here. And this must be what's interfacing between the board and the LCD. Let's take a closer look at that. Just a little strip. It's very flexible. It's kind of rubberized, but you can see the little striations in there, and they happen to be the same width as the width of the solder pads on the board, as well as the strips on the LCD. So I don't know if you can see that. Let's see. It's going to help you see it. Yeah, you can see those little striations on this side here. That's what's making contact with this strip, which is making contact down here with the board. So let's see how that. Oh yeah, there we go. Look at that. See that? That's pretty obvious. So we have a crack right here. See if this comes. Yeah, it comes right out. So this is our mounting block. This sits. Oh my gosh, look at how bad it is on the bottom. This sits into the board. Our LCD sits flush against here, and this kind of sandwiches the LCD to this, and really your little strip is going to lay right in this little seam here, and the downward force is going to push down and force the strip against the board, and it should also force the LCD against the board like that. So there you go. So your strip's going to sit right here in this little seam, and then it's going to press on the bottom. It's going to make contact with the bottom of the LCD, and I bet you that you're just not getting solid contact due to this crack. There's no way. And that's probably why our third one is making no contact, because it's cracked right there terribly. It's really just cracked all the way around, so that's in rough shape. I bet that's our LCD problem right there. So I have 5 other ones. The odds that all 5 of the other ones of these are cracked as well are, I'd say, low. So I'm hoping I can pull one off of the other and install that. So I'll go try and find a good one from another unit, and I'll be back. Got pretty lucky. The first one I checked, no cracks. So I'm going to throw this new one in. Not new, but intact. I have the strip in there. I think it's aligned. Throw the screen in there. And let me see. Alright, it's installed. Let me put the ribbon cable back on. I'll show you how this kind of worked. Kind of interesting. So again, you see the holes in the side of the ribbon cable here. They just fit right inside these little studs here. And once you get them in, you can slide this over it. And on the back, I'm going to drop the screws. It's got this soft little pad to push on the top of the ribbon cable. Just put that on, tighten her down. Magnetic screwdriver. There, that's it. Okay, let's plug it in, see if that helped. Alright, moment of truth, here we go. Again, we're upside down. Hopefully we get something different. Yeah. Oh, so close. We almost have it. That last one there, I don't know what that is. I'm not sure what that's about. It's not quite right either. See, I got it to go there. Again, that's just a connection issue. Anyway, we're about there. Maybe that's it. Let's see. Yeah, I got it. Let me push some buttons here. See what we can get. Okay, so that's, where am I at here? That's resistance. And let me change the scale, see if that changes anything. Yep, should change the position of the decimal point. Yeah, seems to be working. Let's try, what's next? Current. Now let's change the scale here. Seems to be working. I'm not sure what that looks like. The division symbol. I'll have to see what that is. And let's go to volts. Yep, that's volts. Let's see. Oh, I see. That's just positive. It's supposed to be the positive versus negative. Yeah, that's looking really good. So one thing I'm going to do before I put it all back together, I'm going to check some voltages here because I imagine any of these electrolytics are really old and they need to be replaced, and they're going to be filtering our power rails, and then B, our regulators here, they're old as well. 6 volt, negative 5 volt. These regulators might be, you know, getting old and wearing down as well. So let's see. Some test points here for voltages. Test point 2 is positive 13. Test point 3 is positive 6. Test point 4 is minus 5. Test point 5 is minus 10. So that should be easy enough to locate and test those. And if any of those are off, try and get those corrected. But display's still working. It looks good. So I'll check those voltages next. Okay, I checked all the voltages. Everything checked out just fine. No concerns there. So I put everything back together, put it back in the case, cleaned everything up really well, got all the stickers off, was able to clean the front faceplate up really nicely, including the buttons. So everything looks really nice, and it's time to test it out. So I have it hooked up to my HP E3612A power supply that I just repaired. So we'll start out by checking voltages. Powered on, power on the supply, and we'll start off the lowest range that it can go, really 2 volts. It's got the 200 millivolts, but the supply isn't really capable of that kind of resolution. I guess we can try it out. So we'll be in the 200 millivolt range, and it's already reading, you know, 75 millivolts. So if I increase that, yeah. So we'll keep it in the 2 volt range. And I'll put it at 1 volt on the supply. See what we're reading on there. Okay, 1 volt on the supply, 1.084 on the multimeter. Very good. Let's jump up ranges here, and we'll go to 10 volts. 10 on the supply, 9.982 on the multimeter, very nice. Let's go up the next range, and we'll go to 50 volts. $50 on the supply, 49.79 on the multimeter. I'm okay with that. And we'll keep it in the 200. And we'll go up to 100 volts on the supply. This supply can go up to 120, really 130, but going up to 100 is about as good as it'll get. So let's do 100 volts on the supply, see what we get on the meter. Tough to. There we go. 100.0 on the supply, 99.6 on the multimeter. I'm pretty happy with that. So first of all, my supply isn't calibrated, and then of course I haven't calibrated this. So for them to be that close, all the way up the range from really 1 volt to 100 volts I'm pretty happy with. So next let's do we'll do resistance, and for that I'll just get a few resistors, I guess. I have some 8 ohm power resistors. I suppose I have 4 of those. I can do one and then connect some in series to get up to 32 ohms, so that'd be good. So we'll start with that. Okay, so I have it hooked up to my 8 ohm power resistor. Obviously that's looking pretty good at 8 ohms. Put one of those in series just to get 16 ohms, and we'll see how that looks. And here we go. Should be about 16.13. That looks good. Okay. And I'll have to dig up some resistors to check the higher ranges, so let me get some of those and I'll be back. Alright, I have a 5.1K resistor hooked up, and I'm now in the 20K range, and you can see it's reading pretty well, 4.95. Let's see, I have a 10K resistor here. Let me try one of those. Stay in this 20K range. $9.97K, good. Alright, I'll have to find some more to bump it up to the 200K range. So, still reading okay in that range, but I want to try and find some higher value resistors. Alright, here's a 47K. See how that looks. Yeah, 47.3, looking good. And I'm not sure I can go much higher. I don't have many higher value resistors to go in the 200K range. So I'll have to stop there. So we'll just jump ahead to current. Alright, I have my meter in series with the output of my power supply, and my power supply is limited to 50 milliamps, or 500 milliamps, excuse me, so that's as high as we can test it. So I'm in the 200 milliamp range on my meter, and so I'll go ahead and crank up the voltage to draw some current. And I'm going through my 8 ohm 50 watt power resistor. So here's my voltage output on my supply, my current output on my supply, and then of course the current reading on my meter. So let's turn it up to 100 milliamps on my supply and see what we get. So 103 on the supply, 105, 106 on the meter, pretty good. Keep going here, let's go to 200. And okay, of course gotta change scales there. So 201 on the supply, 207 on the meter, still not bad. And let's keep going, let's just go to 450. So 451 on the supply, 467 on the meter. So, you know, a good 15 milliamps off. Yeah, I'm still happy with that. Again, I can calibrate this later, but everything at least is reading very close. Again, the supply isn't calibrated itself, so who knows which one is closer to accurate. They could both be off. So anyway, this guy's fixed. Pretty happy with that. I was able to clean it up really well, so this is going to stay on my bench. I'll be able to use this in the future. And I'm going to take a look at the next 5 of these multimeters and see if there's one that's feasible for fixing. If there is, there'll be a part 2 to this video. If not, I'll probably just have a bunch of scrap laying around for that. So either way, thanks for watching. I appreciate it. Subscribe if you haven't subscribed, and we'll see you next time. Thanks.